Hello, welcome back to Algebra. I'm Jason with mathandscience.com. Today what we're going to do is learn about graphing parabolas. Specifically, we're going to focus on shifting a parabola up and down. So I want to give you the big picture and then dive into shifting these things up and down so you understand what we're doing. We have the basic shape of a parabola. We talked about it in the last lesson and in fact for a very long time in algebra. And this parabola is centered on the origin right here where the vertex of it is touching the 0, 0 point in the origin. Well, with a very slight modification to the equation of this parabola, we can move the parabola. It'll still retain the complete shape. Everything is exactly the way it is. But with a very simple change to the equation, we can move that parabola anywhere we want. It's almost like grabbing it with your hands. You can move the whole thing around in anywhere in the xy plane. Now, usually most books will give you the equation of a parabola in order to do that, where you can shift it along the x direction and then shift it along the y direction. And by shifting it in x and y, you can move that parabola anywhere you want. But what I'm going to do is break it up into two pieces. First, we're going to talk about just shifting this parabola up and down. What does it look like when we change the equation just to move the parabola up and down? Why do I start with that? Because it's really easy to understand, okay? Then after that, in the next lesson, we're going to shift this parabola left and right. We're going to grab it and just shift it along the x-axis, and you'll understand how that is accomplished. Then we're going to put both of the two things together, shifting it along y and shifting it along x, and that's going to allow us to pull this parabola anywhere in the xy plane. And by the way, this process applies to any function, right? Anything at all. Cubic, x cubed things. Later on, we're going to apply it to circles. We're going to be graphing circles in the xy plane. We're going to use a similar idea to move that circle anywhere around the xy plane. So what you're learning here is not something just for parabolas. It's really used for any function. All right, so let's go dive back into it. We're going to be learning how to shift this parabola only up and down in the y-axis, along the y-axis. So here we have what we talked about in the last lesson, last couple of lessons. I left it up on the board. We have a parabola, y is equal to x squared. We have a table of values, and we plotted some points to get the general shape, all right? But don't forget that parabolas are, in general, here I have x squared. This is the parabola we've graphed here. But in general, right, in general, the actual equation of a parabola, the most basic form of this guy, is really a times x squared. Remember, we talked about this in the last lesson. The number a is just a number. It could be 1, 2, 3, 4, so on. It could be -1, -2, -3. It can be fractions as well. But this number controls the steepness of the parabola. If a is a bigger number, this parabola closes in and becomes very narrow. If a is a low number, like a fraction, like 1/2, then this parabola opens up like a flower, okay? And then if a becomes negative, then the parabola flips upside down and is a frowny face down here. And as it gets deeper negative, like -4, -5, -6, then the parabola is very, very closed off downstairs. Now, we've talked about that before. That's more of a review. We've done that in the past. This is the general equation of a parabola. Now, what we have graphed here is this equation where we have basically chosen that a is equal to 1. Because there's an invisible a here that's not there, because in this case, a is just 1, so you don't have to write it. So this is the case of that. So we're going to focus on learning how to do this for this very simple case when f of x or y is equal to x squared. So here's the table of values running from -3 to +3, and we have the corresponding outputs. I want you to remember these numbers, 1, 4, 9, and then 1, 4, 9 in this direction. And the parabola, of course, is centered at 0, 0. Now what we're going to do is we're going to make a very small change to this equation to shift this parabola up in the y direction, and then in just a few minutes we'll be shifting it down. That change is so easy to understand. That's why I'm incorporating it first. Let's take a look. Let's change this equation. This triangle means change. You're going to learn that in calculus, so it's my little shorthand. Let's change this equation to the following. Instead of f of x is equal to x squared, which is what we graphed over there, let's change it to y is equal to x squared. This is the basic shape of what we've graphed, but we're going to make one small change. We're going to add 1 to it. And that's going to end up shifting this graph, right? So let's see how that's going to happen. Let's draw another table of values. So we have to have inputs on the x and outputs on the y, like this. And I want to use the same values here, so I'm going to go -3, -2, -1, 0, 1, 2, and 3. And let's see what's going to happen. The equation is now x squared plus 1. So you see what's really going on here is we're taking essentially the basic curve that we've already graphed, the x squared curve, and whatever values we calculate for y, as we stick these numbers in, we're going to calculate the y value, but before we assign it, we're going to just add 1. So what's going to end up happening is it's going to be a carbon copy of this entire table. It's just that every one of these output values for y has 1 added to it because we're just adding 1 on the outside. So let's just go ahead and do it here. If we have negative 3 squared, that's going to be 9. 9 plus 1 is 10. So 10 goes here. Actually, I'm going to use a different color. 10 goes here. Negative 2 squared, that's 4 plus 1 is 5. Negative 1 squared, that's 1 plus 1 is 2. 0 squared plus 1 is 1. And then 1 squared plus is 1. Then you add 1 to it, you get 2. And you can see the pattern. You're going to have a 5 and a 10 here. Because if you put that 3 in here, it's 9 plus 1 is 10. So the numbers that you get for this equation is no longer the same numbers that we started with over there. We have a 1 kind of, this is a mirror image kind of. You can see the symmetry here because we have these guys are symmetric with one another, these guys are symmetric with one another, and these guys are symmetric with one another. Notice we had the same symmetry here. So these were symmetric, centered about this kind of this mirror image, or kind of the center point here in the center. We still have a mirror image, but the numbers are actually just different now. So when we plot this thing, what are we going to get? Let me go ahead and just do a sketch of it right here. What do you think we're going to get? If you notice what's going on, all that's happened because we added the 1 is every one of these output values just has a 1 added to it. So if you can visualize your basic curve, the one that we graphed a long time ago, every one of these points is exactly kind of relatively where it should be. It's just there's a 1 added to it. So for instance, this point is going to be shifted 1 up because instead of 0, 0, it's now 0, 1. So the bottom of the parabola actually falls 1 unit higher right there. And everything happens to all the other points. These points are shifted up. These points are shifted up by 1 unit. And these points are shifted up by 1 unit. So what ends up happening is if I'm not going to sit here and plot every little point. I mostly want to sketch things for you. But this parabola is going to have the same exact shape as the one on the left-hand board. Except it's going to be shifted up exactly 1 unit because this is 1 unit up. So it's going to be shifted up 1 unit. So the bottom line is when you take a quote-unquote basic curve, I always told you I want you to think of the x squared, y is equal to x squared. That parabola is the basic shape of a parabola. It's the most basic one you can have. Burn it in your mind, I told you. Remember? This is why. Because that basic shape, instead of looking at this equation as some crazy equation, this is how I want you to think about it. This is the basic shape of the thing, and I'm just adding 1 to every single output of this function here, really, the y values. I'm adding 1 to them. So I take everything in this table, I add 1, and that, because of that, shifts the whole graph up because every one of those points are in the same locations. They're just shifted up 1 unit. All right? Now, what do you think is going to happen when we shift it by some other number other than 1? Right? Let's go ahead and do that. And let's change this equation again. Let's make it y is equal to x squared plus, drum roll please, let's make it a plus 3. What do you think is going to happen? Well, what's going to happen is we're going to run it through a table. We're going to basically get these base values here for the x squared, but instead of adding 1 to it, we're going to add 3 to it. And so what's going to end up happening is that entire parabola is going to be shifted up 3 units. So the bottom line is to shift really any curve, but we're talking now about parabolas, up along the y-axis. You just add however many units you want on the right-hand side, and that's going to shift all the values up in equal amount. So just because this is probably the first time you're seeing this, I want to make sure everybody's on the same page. So let's go x and y is equal to x squared plus 3. And we're going to just do it real quick because it only takes a second. So negative 3, negative 2, negative 1, 0, 1, 2, 3. And now we're going to go a little faster because you understand what's really going on. Every one of these points, when we put in a negative 3, we get negative 3 squared, we got a 9, but now we're going to be adding 3 to that. 9 plus 3 is 12. So what's going to happen is you're going to have a 12, a value of a 12 right here. And this is going to be a 7, and this is going to be a 4, a 3, a 4. We have a 3, a 4. This is going to be a mirror image here with 7 and 12. So you see, it's the same sort of thing. We still have the symmetry. This one goes with this one matches with this one. So the shape of the curve remains intact. And it's the same sort of thing. When you put a 2 in, we're squaring it. That's 4 plus 3 is 7. 1 goes in, that's squared, that's 1, plus the 3 here gives me the 4, and so on. And so when you graph this guy, what do you think is going to happen? 1, 2, 3. You're shifting up 3 units up like this. And then the graph of it is basically going to be the exact same shape. You're not adjusting the shape of the parabola. It's the same shape as the basic parabola that you have here, but it's now shifted up 3 units. All right? And so I want to do one in the opposite direction so you understand. What if you have the equation y is equal to x squared minus 2? So here, we're not shifting up any number of units. When you have a minus sign over there, you're shifting them down. Why is that the case? Because the basic curve is x squared, which are these values. When you subtract 2, I'm taking every output and I'm moving them down. So in other words, this center point, instead of being at 0, will be shifted down 2 units. These points will be shifted down 2 units. These points will be shifted down 2 units, and so on. So the curve will look exactly the same, but it will be shifted down those number of units. So just to make sure we're all on the same page, y is equal to x squared minus 2. What values do we get? Well, we have, let's go negative 3, negative 2, negative 1, 0, 1, 2, and 3. And then we have, let's just do the first one. So this will be 9. Negative 3 squared is 9. 9 minus 2 is a 7. And if you go through it, you're going to get a 2 here, a negative 1 here, a negative 2 here, a negative 1 here, a 2, and a 7. Now make sure you understand what's going on here. You might say, well, where's the center point? Where's the symmetry going on here? First, let's make sure the numbers are correct. When you put a 0 in here, that's 0 squared, 0, minus 2 gives you negative 2. A 1 goes in, that's going to give you 1 minus 2 gives you negative 1. A 2 goes in, 2 squared is 4, 4 minus 2 is 2. So all the numbers are correct. 3 squared is 9, minus 2 is 7. So where's the symmetry in this case? The symmetry here is going to be, these numbers are going to be symmetric, these numbers are going to be symmetric, and these numbers are going to be symmetric. So you can see you still have symmetry, but the whole thing is shifted down because all the numbers are shifted down from before. So whenever you draw this guy, you have an x and a y, if I can draw x and y correctly, and you're going to have 2 units down the y-axis. Same exact shape. Nothing is different other than the fact that it's pulled down like that. So far we've taken the basic shape of the parabola, which is x squared, and we can shift it up by adding numbers to the right-hand side of the equation. It shifts all of the values equally up. We could subtract values. That shifts all of the output y values equally down, which means the thing is only going to go up and down in the y direction. Okay. Now I need to do a summary here, but when we do the summary, after the summary, we're going to go off to the computer and I'm going to show you a little demo that's going to make it even more rock solid in your mind. But let me just make sure we're all on the same page. This is shift up 3 units, shift down, that's down, 2 units. All right, so let's summarize. Summary. All right, now we have to generalize things a little bit. If you have the equation y is equal to ax squared. See, in this example, we had just set a equal to 1 to make it the most basic parabola that you have. But it applies to any parabola of any shape. If you have y is equal to 3x squared, the only difference will be the parabola will be very steep, because remember, what is in front of the x squared controls the steepness or how closed off the parabola is. So if you start with any parabola with any number out in front of the x squared, then basically you have no shift. This parabola will be centered on the origin, the vertex will go down and touch the origin. But if you have the parabola y is equal to ax squared plus 1, you're just adding 1 to whatever parabola you started with. And you shift up 1 unit. Now, oftentimes, this is represented a different way. I introduced it to you this way with the +1 on the other side because it makes it very easy for you to understand. But oftentimes in books, it's written like this. If you take this 1 and you subtract it, moving it over to the other side, what you get is y minus 1 equals ax squared. This equation is exactly the same as this one. So in your book, if you see the -1 on the left, a lot of times people are like, what does that mean? Well, it's written that way for a reason I will get to in just a second. But mentally in your mind, you can imagine that 1 going to the other side, meaning you're going to shift the thing up. Let me get the rest of the board in place, and I'll go back and talk a little bit about this minus sign. For now, just know you can move the 1 over and write it like that. If you have y is equal to ax squared, some parabola, plus some other number like a 3, then you shift up 3 units. And again, this can be written, instead of writing the 3 on the right-hand side, if you'd like, you can move it to the left-hand side, which a lot of books do, so I want to get you used to this. All I've done is take that 3 and move it over. This is exactly representing the same thing as this. It is a parabola shifted up 3 units. And finally, let's go in the other direction. What if you have y is equal to ax squared minus 2? This is a downshift. This is shifting the whole parabola down. Shift down 2 units. All right? And then you can take that 2 and you can move it over by adding 2 to both sides. And then it'll be y plus 2 is equal to ax squared. So you might see the parabola with the shift, instead of written on the right-hand side, it might be written on the left-hand side with a plus. So when you have this guy, it's shifted down 2 units. So I need to talk a little bit about this before we leave the topic, all right? Why do we move and write the shifts over here next to the y, right? I've tried to introduce you with tables, a table of values, to show you that when you have a shift here, you're just adding numbers to the y values, and it's very easy. If you add 1, you shift the whole thing up. If you subtract 2, you shift the whole thing down. But usually, or I shouldn't say usually, oftentimes we write equations like this where the shift is written on the other side of the equal sign. But it gets confusing because this is y minus 1, but yet it means you're shifting up 1 unit. So when people see y minus 1, it appears that you're shifting a thing down because it has a minus sign there. But actually, it means you're shifting it up. So it's kind of opposite. So you might say, well, why do I even write it like this? Why am I putting it over here? That's confusing. It's because later on when we get to the equation of a circle, I can't get too much ahead of myself, but when we get to the equation of a circle, this is going to be the only way that is easy for us to write the equation of a circle down. So the reason we put the numbers over here is because this number, it's written next to the y, and it reminds us it's a shift in the y direction. This number is written next to the y, so it reminds us it's 3 units shift in the y direction. This number is written next to the y, so it reminds us that it's a 2-unit shift in the y direction. But when you see the shifts written down next to the variable, you have to remember that it's shifted in the opposite direction. Y minus means shift up. 3 minus means shift up. Y plus 2 means shift down. So in your mind, you have to think, if the shift is written next to the variable on the left-hand side of the equal sign, it's shifted that many units, but opposite to the sign that's kind of written there, right? And if the shift is written on the other side, like I've kind of introduced things, that's actually more easy to understand. It's shifted up and down with the same sign. So in your book, sometimes they'll write it like this, and they'll say, how many units in what direction is this parabola shifted? And you'll have to look at the plus and say, well, that means it's shifted down. Mentally, you can move the 2 to the other side, make it a minus sign, whatever's easier for you, but that is why it's written that way. All right? So then, now that we have that out of the way, I can write, these are shifts with certain numbers, I can write in general. This is what you would typically see in a book, right? In general, the following is true. If I have y minus k is equal to ax squared, where k is just some number, it could be 2, 3, 4, whatever. If k is greater than 0, then you shift up k units, right? But if k is less than 0, you shift down k units. All right, so let's think about this in terms of what we just talked about a second ago. If you have, let's pick k is equal to 1. K is now 1. That's a positive number, so it's y minus 1. And I just told you when it's written over here, you have to, if it's a minus sign, it's actually shifted up. It's opposite kind of in your mind of what the sign kind of leads you to believe. So it's shifted up 1 unit. But if k happens to be negative, let's pick k to be -2. -2, right, means y minus a -2, which means y plus 2. So if you ever see y plus anything, it's always a shift in the down direction, which means is exactly what I've written it here. So this kind of thing is the math gobbledygook that you'll see in most textbooks. They'll write it like this and have these little cases. But those are useful, and that is mathematically what it is all true. But it's much easier to think of it in terms of numbers, actual numbers. So if you have minus a number, you shift that parabola up that many units. If you have plus a number next to the y, you shift it down that many units. That's if the numbers are written on the left-hand side of the equal sign like this. If they're on the other side of the equal sign, then you just follow the signs as they're written. So now what I'd like to do is go off to the computer and show you more interactively how these shifts work. And I can do a lot more examples a lot more quickly when I have the computer going. So let's walk over there and do that right now. All right, welcome back. So here we are at the basic parabola. I want you to ignore this right now. I want you to ignore what's written on top of the axis here. I want you to look over here. We're graphing the equation y is equal to x squared. This is the basic parabola we've been graphing forever. It goes and touches the origin. And here's the table of values. So you can see that it's correct. So when you square this, you get a 1. When you square this, you get a 4. You square the -3, you get a 9. Here I'm going up all the way to positive and -5, squaring it, getting 25 on both sides. So you can see it's symmetric here. Now, I want to increase this by 1. And I don't want you to look at this yet. I want you to look over here. I have x squared plus 1. You see what's happened? All I've done is I've added 1 value to the output, to the y value of my table of values, and that has shifted the graph up by 1, right? If I increase by 2, all I've done is I've added 2 values. So this was 25 before, and so on. Originally, it was 16 for the second slot here, but when I shift it up by 2 units, I get 18. So every output here is now added, has a number 2 added to it, and that is what causes the curve to go and shift upward. Now I want you to turn your attention. This is if the shift is written on the right-hand side. You can pull the 2 over, and you can see how it's written in terms of, I don't want to get into the terminology right now, but when the shift is written on the left-hand side, you just move that 2 over. So when it's a minus sign here, you're actually shifting it up. -3 shifts it up. And then, of course, this is off the screen there. And then when -1 is, again, shifted up. And then when you go back to -0, that means it's not even there at all. It's just a basic parabola. When you go in the negative direction, you can see the same thing. When you have a plus sign as a shift written on the left-hand side, you're shifting the thing down. And you can see what's happening here. When you go back to the basic parabola, x squared, notice we added 25 up here. When I go and shift down 1 unit, all I'm doing is subtracting 1 from every output. So now I have a 24, and everything in this column is basically has a 1 subtracted. And of course, I can see the shift here is a -1 on the right-hand side, so I'm going down. But I can move that 1 to the left, making it y plus 1. And so you need to get in your mind that when you see these shifts written next to the variable, plus means down, minus means up. And as I go deeper and deeper in the negative territory here, +3 is shifted down 3 units, and my table of values reflects that. Now, there's one more thing I want to show you before I close, and that is the following thing. If I change this equation so that it's not just y is equal to x squared, it's y is equal to 2x squared. Or maybe I change this equation so that it's y is equal to 4x squared. You see the table of values updates to reflect. But the same thing happens with the shifting, right? If I shift up 2 units like this, all I've done is add 2 units to the output. I've shifted the same exact shape of the curve. Notice the shape of this curve is very narrow. We can crank it up even further and see that it's really narrow. But anytime I have a shift here of a minus sign over here, and y minus something, it shifts up that many of units. And then when it's y plus something, I shift down that many units. It doesn't matter what the shape of the curve is, even if I go upside down. Let's make it -4x squared. This is y is equal to -4x squared. So that's an upside down parabola, and it's very narrow. Whenever I add numbers to it like this, then I shift the thing up. And of course, I can see it over here as a y minus in the shift. And then, of course, I can go the other direction, y plus in the shift. So the thing I want you to really understand the most of all of this stuff is any parabola, no matter what its shape, right? If you see the shift written next to the variable like y minus like this, it's shifted up. When you see a value y plus like this next to the variable, it's shifted down. If you want to mentally move it to the other side of the equal sign, then you can see exactly how it affects the table of values a little more clearly. So now follow me back to the board where we're going to wrap up the lesson. All right, I hope you enjoyed the computer demo. It's very easy and interactive to see how things change. And I put that table of values in there to show you there's nothing magical happening with the shifting of parabolas. A lot of students will just memorize that how to shift them up and shift them down, but they don't realize why it's happening. It's basically happening because the basic shape of a parabola is governed by this. Here we chose a is equal to 1, but it could be 2x squared or 3x squared. It's going to change the basic shape of this parabola here. Here you have a x squared plus 0 invisible right here, and that means there's no shift at all. But when you add 1 to it, you shift the thing up. When you add 3 to it, you shift it up 3 units. When you subtract numbers on the right-hand side, you shift it down. But for all of those cases, even though we can write it like this, oftentimes in books you'll see the shift written over next to the variable. And that is so you can say, okay, the y direction is shifted this many units. The y direction shifted this many units. The y direction is shifted this many units. By putting them together, it's easy to see which axis is being shifted there. But you have to remember a minus sign means shift up and a positive sign means shift down. So make sure you understand this and then go on to with me to the next lesson where we're going to no longer talk about shifting in the y direction. We're going to grab that parabola and shift it left and right in the x direction. So follow me on and we'll do that right now.